recording. Okay, so today we will start with a new topic about a new kind of data structure called linked list. Okay, and previously the data structure so far we have learned is array list. Okay, and we also learned stack and queue. Okay, and when we discuss the implementation of stack, we use array-based. And for queue, we discuss like the circular array. Array-based implementation, okay. And also for array list, basically the concept is kind of one after the other, is it? So one after the other. Okay, so it's all kind of in sequence, is it? Either like LIFO or FIFO, something like that, okay. And what today we will learn is a new kind of data structures called linked list, okay. Now, let me see if I can find it again. So the linked list, so based on the name, there is a word called link. So there must be something that you can link together, is it? So basically for linked list, its basic building component is a node. A node, okay, a node. So what is a node? A node is looks something like this. We can kind of visualization like something like this. So a node has two parts. So one part, it can hold some information, or we call it data. Data or information. Okay, there is another part. Second part is it's a point to a next node. To next node. Okay, so this is a basic building unit. Then with this basic building unit, it looks like then you can, so you have one node, is it? Then you can have another node. And you can connect them together. So here we connect them together, is it? Then you can have another node. Then you can also connect it to the second node. Then you can have another node. Then you can connect to the third node, is it? And you can keep doing something like this. So you connect all of the nodes together. So this also kind of look like if you recall the railroad. There for the railroad, and then you have the cart, is it? And then it has a hook, and the hook is the next cart, is it? Has a hook to the next one. So kind of something like this, is it? But each one is a cart, is it? So here, each unit is a node, and a node has two parts, okay? A data part and another part It's point to the next node. Okay. Okay, point to the next node. So like over here, then if we can define the node as a class, okay, the class. So it has the data part, and it also has the next part. So the next part point to a node, so what's the type? They should also be a node. So over here, you use yourself to define an instance variable. That's allowed, okay? So you can use yourself to define it. So basically, this just means, okay, it's going to be the next. So for this class, it's quite simple. So you have two parameters. The second parameter is also the class type itself. Then you just do the assignment. Okay. So that's regarding the node unit. Okay, this is the basic building component. Okay, so you have one, and then you connect it to the next, and then you have another one, you connect it to the next. We can keep doing like this. Okay, we can keep doing like this. And when we connect all of them together, then this is called a linked list. So a linked list basically is just a number of nodes that you connect them together. Okay, then that's called a linked list. And all of the data is stored in the node. So all the data is going to be stored in a node. Okay, so the linked list, so it's a number of nodes connected together. Okay, so linked list is quite important, is because it's the starting data structure on linked ADT. Okay, ADT is abstract data type. So basically just some data structure. Okay, so it's a starting point for linked data structure. Okay, the one we show here, it's a simple one. It's simple, and it's one way linked list. So from beginning to the end, that at the very bottom, the very last is this is the last node. And for last nodes, its next doesn't point to any other nodes. Okay. Okay, so that's we kind of see is it what a linked list is. Okay, then let's see. Suppose you have some numbers, you store them in a linked list. So 100 you stop here, then 200 you stop at the second node. We can do this. Is 300 you store it in the third node, and the 400 you store it in the next node, and the 500 you store it in the next node. Suppose this is the end. Okay. And within this linked list, then let's do some analyze. So 100, this is the first node. First node, is it? Then just think about, if you know the first node, basically you know the whole linked list. Why we see that? Because once you know the first node, through the first node, suppose we call first node first. then through first is next. What is it? This is going to be the second node. Is it? Then you can get to the second node. Okay, once you know second node, then through its next. Is it? So through its next, we can get to the third node. Is it? We can get to third node. And how do we get? Then in this case, second node, how we express it, it's first, next. This is second, it's another dot next. Then you can get to the second node, the third node. Is it? Okay, third nodes, if you want to get to the next one, you can do another one. The first, dot next, then another dot next. Is it? Then you can get to the fourth one. And the fifth one, then you do another dot next. And then you can get to the fifth one. Is it? So over here, what I'm trying to explain is once you know the first node, then basically you can get to all of the other nodes in this linked list. Okay, in this linked list. Okay, so this is a linked data structure. So it's through a specific field we call next to connect to the other nodes. Okay. Okay, and then next, let's recall whenever we discuss a data structure, we always discuss how to add a new item, and how to remove an existing item. Is this something like that? How to get some value from the data structure? That's the operation that we care about. So for stack, when we add, we can only add at the top. For queue, when we add, we can only add at the back. So, and when we remove from front. Okay, so they have different characteristics. And for linked list, the benefit for it is when we do add, we can add anywhere. So basically, we can also, we call it insert. We can insert it anywhere. Okay, when we do remove, we can also remove anywhere. Okay, so that's it's different from stack or queue. Okay, and also the array list, then it's also a list, but it's has a feature of array. Okay, so it's a little bit different. But anyway, it can be anywhere here for linked list. Okay, then anywhere, then how are we going to do the insert and the remove? So next, let's take a look. The operation, okay. So over here, we assume our linked list is in ascending order, okay. Assuming one, okay. So then let's see, we have this list. Just assuming we have 5 items. We have 100, 200, 300, 400, 500. Okay, now assuming we want to insert 350. And if we want to insert, then it should be between 300 and 400. Is it? So how do we do the insert? Is it? How do we insert between 300 to 400? So if you want to insert, then the very first thing you need to do is what? You need to create a new node. That's the very first thing we needed to do, okay? So we create a new node with 350. Is it? You create it, and then you also need to know you're going to insert between 300 to 400. Okay, assuming you locate the node you're going to insert, you know that you're going to insert after 300, and assuming we call 300 a cursor node. Okay, cursor node. Then how are we going to insert between 300 and 400? So if you want to insert, then you need to break the chain. So this looks like a chain. You need to break out this chain. Is it? So we need to do what? We first need to connect, because 350 is going to point to 400. So you need to set its next to 400. Okay, and now 400 has 2 nodes point to it. That's not a linked list, is it? Then you can reset 300 is next to 350, is it? In this case, then you can insert 350 between 300 and 400. And just think about it. Compare with, you have an array. So 100, 200, 300, 400, 500. Assuming we have an array, if we want to insert between 300 and 400, then you need to do shifting. And a lot of shifting if your data size is large. Is it? If we compare this to, then definitely this is more convenient, this is more efficient. Is it? You don't need to do all of those shifting, reassign the values. Okay, you just create a new one, set it to the next, and bring the previous ones next to this new node. That's it. Is it? So it's much more efficient compared with this kind of version. Okay, so that's why we need a linked data structure. Linked data structure is that when we have a lot of insertions, because it's just think about it, if you use an array, if you have a lot of insertion, each time you need to do heavy shifting. But with linked list, you don't need to change any of the new location, any of the existing location. You just make the new one as at a point to the right location. Just reset a previous one's next. Then we get it done. Is it? Okay, so this is regarding how we do insert. And this insert is insert between 300 to 400. Okay, between 300 to 4. Okay, so that's this case. And then next, let's see. There are a number of cases we needed to think about, is it? So when we do insert, so here we have 100, 200, 300, 400, and 500. Okay, this is a linked list, is it? And we know the first node. Okay, and suppose you want to insert 50. And if you want to insert 50, it should be at the very beginning. Is it? So the way to do it, you still need to create this new node. Okay, and after it, you need to set its next point to first. If you set its point to first, that's this linked list still identified by first, so it's still start from first. So that's not all right, is it? You also need to reset first to this new node. Okay, so that's this case. Okay, that's this case. And then next, let's see. We want to insert, suppose, 550. At 550, then definitely it should be insert at the back. Is it? At the back, how are we going to change it? Okay, so we need to change the last node. Get rid of this. Reset its next to this new node. And this new node's next need to point to the last, to nothing, is it? So it's point to a node, basically, here. Okay, so that's regarding this case. And also when we discuss insertion, maybe at the very beginning, you don't have anything, is it? So you have 100. So you create this node, is it? Create this node. And then what do you need to do? You need to assign first to this new node. Okay, so when your linked list is empty, then you create a node. Then you need to assign first to it. Okay, so this is just different scenarios when we do the insertion. When we consider insertion, we need to consider insert the different cases, is it? It's insert at the beginning. Insert at the beginning, insert in the middle, and insert at the end. 3 different cases when we do the insert. Okay. And also we need to think about the case when the list is empty. Okay, we just create a node that, and we assign first to this new node. Okay, so that's just different cases. Okay, and then in linked list, there is another concept. So let's see. So we have 100, we have 200, 300, 400, and 500. Is it? So, so how are we going to suppose to do some operation on each of the node? On each of the node. So there is a concept is in linked list. So visiting node by node. So we do node by node visiting. So this concept, we call it traversing. Okay, so anyways, just you do node by node processing. Maybe print out, maybe read, maybe do something, etc. So this concept is called traversing. So how are we going to do node by node traversing? Suppose, assuming print out. Okay, assuming print out, etc. How are we going to do it? And previously we say, for a linked list, we only know the first node. Is it? Okay, and if we want to print out, okay, first, then it's easy. First dot data. Is it system data out dot print the data part? Then you can get 100 output. And how about 200? Okay, previously we said, okay, you can still do print first dot next dot next, then data. Is it? Because first dot net, this is dot next is what? It is a node. It is this node, and node has data. Is it? So this will give you 200. Then for 300 is what? First dot next. This is second node. And then it's dot next. So this is going to be the third node. Is it? Third node is data part. Then you will get 300. And 400, you will add another net, 500. So if we always use the first, if you have a million, then you need to have a million dot next. That's not a good way, okay, to write a program. Is it? Okay, so in order to do traversing, then we can do something like this. So 100, 200, 300, 400, 500. Is it? Okay, so we have first pointer. So first variable, get the first node. Okay, so the idea is, can we have some kind of cursor that it can move? Is it? Yes, we can always do that. So we can set this cursor initially point to the first node. Is it? So that's easy. That you can do. So it's a node. Is it? Node cursor then equals to first. Is it? You can assign cursor to the first. Okay, then we can advance. We can let a cursor point to 200. How are we going to do it? If we do something like this, cursor then equals to cursor dot next. So cursor dot next is 200, but you then assign it to cursor. Is it? So now cursor is going to point to 200. Is it? And if you do this in a loop, then next iteration can move to 300, and then it can be advanced to 400, and can be advanced to 500. Is it? So each time it can be advanced. Is it? It can be advanced to the next node. Okay, so with this operation, we can advance it to the next node. So this is just like in loop. For loop variable, we can do plus plus. Is it? But here we don't have the plus plus. We just have we advance the cursor to next. That's it, to next. Okay, then within the loop, then you can do, after you advance it, then you can get to the new information, etc. So you can output its data here. You do print data, then you advance. And next, then, so within the loop, first it output 100, then it's moved to 200, then it output to 200, then it's advanced to the next. Is it? So when it will stop its iteration, so it's when cursor advance, when cursor is a null pointer, is it? It's when it points to nothing basically here. Okay, then you cannot advance. There is nothing for you to advance. So here is the termination condition. So termination condition is the cursor is a null. Is it? So if we want the loop continue, then it shouldn't be a null. Is it? So while it's not a null, then you can always do this. And when it is null, then it will stop. Okay, so then this idea, we call it traversing. And for traversing, then we using node advance. Okay, using the cursor advance. Okay, instead of the a number of the data next. Okay, that's not going to be efficient. Okay, so this is the idea of traversing. Okay, very important. So far in linked list, we already discussed two operations, insert and traverse. And the third one is remove. Remove, okay, so let's see. So we have 100, then we have 200. Then we have 300. Then we have 400. Then we have 500. Okay, so this is a list. Is it? Assuming you want to remove 400 node. Is it? How are we going to remove? Is it? So the removing in the linked way, then what you can do is you first need to identify this node. Suppose we call it a cursor. Okay. So how are we going to remove it? So if you want to remove, you need to get 300's next, set to 500. Is it? Then this node is still there, but it's not in the linked list. So basically, this is just some floating ones. So basically, it will be garbage collected. Okay. So you just set 300 to 500. Then basically, you can remove it. So 300, now how can we identify? So we can call it a precursor because it's ahead of the cursor. So we need to know which node is ahead of the cursor. Then we just set its next, 2 cursors next. Okay, so this is this case. But there's some other case we also need to think about. Suppose you want to remove 100. If you want to remove 100, how are we going to do it? The remove at the beginning. So if you want to remove beginning, basically you need to set first to 200. This node is still there, is it? Then it will garbage collected. Okay, it's gone. So this is to remove at the front. For you need to reset first. Okay. And then let's see, remove last. Remove last node. To remove last node, how are we going to do it? Because what it cares is the one previous it. The one previous, then you need to reset its next to null. Is it? Then this one will be garbage collected. So it's gone. Is it? So when we discuss remove, we need to also consider different scenarios. Is it? Remove at front, remove in middle, and remove at back. Okay, so different scenarios when we consider remove. Okay. Okay, so that's regarding remove operation. So we kind of understand the idea of for the linked list, how we insert and how we do traverse and how we do the remove. Okay. Okay, so, and I think today let's just